Okay, now I'm to question 5. This is question 5. Question 5 ukhuluma ngama reaction rates. This question is from this question paper November 2020, and then in the description below uzothola ama links for amanye ama questions akhona kule question paper le. Right, now question ethi ifundeka ngale ndlela bathi the reaction of calcium carbonate and excess in capital letters, excess, I think this is key, but asibone ukuthi nasichubeka nale question, how does the excess dilute hydrochloric acid play a role kulelo kanje kule question le. But if bayifake in capital letters, it means there's some significance, bazama emphasize something ngithi, but athi sichubeke nokufunda le question bathi okay, I think it's past. The reaction of calcium carbonate and excess dilute hydrochloric acid is used to investigate one of the factors that affects reaction rate. So, sithatha two yama substances, siyawa reactisa, we want to investigate the factors that affect what? Reaction rate. The balanced equation for the reaction is given below. Calcium carbonate, yes, it balanced, okay, hydrochloric acid, calcium chloride, water, water, H2O, carbon dioxide, and then but the same mass of calcium carbonate is used in all the experiments, and the temperature of hydrochloric acid in all experiments is 40 degrees Celsius. Sorry about that. Okay, the reaction conditions for each experiment are summarized in the table below. So they conducted 3 experiments, experiment A, B, and C. If volume was kept constant as well as the temperature, and then the concentration of hydrochloric acid is also kept constant. Now, in the last column of the table, bakhuluma nge-state of division of calcium carbonate. Okay, the state of division basuke bathi we are dealing with a solid. Uyabona i-calcium carbonate is given as a solid in the chemical equation. So therefore, the solid calcium carbonate can exist as granules, lumps, or as a powder. A granule, it's sort of like isanhlabathi, so it's a soil inyana, so like inama grains amancane, and then ama lumps is sort of like inesgadla nyana ngaphakathi leyo calcium carbonate, and then the powder it's something like angazi ukuthi i-medication niyayithatha na guys, but something like a grain paso, yabona, something a powdered, something a fine kanje, so yabona, something a fine, something like a powder kanje, so ayinama grains, ayinama lumps, just but now ibamba vele isa like powder, sa sherbet uyazi le ayiseni sugar le bathi sherbet, yeah, ifana nayo. Okay, all right, again, now lana ke, remember we are conducting an experiment, and then some conditions were kept constant. What are we investigating? We are investigating the factors that affect any reaction rate, right? And then some factors were kept constant as well. Now, in an experiment, kumele uwazi i-dependent variable ne-independent variable. This is important ukuthi ukwazi again, ne? Especially ku physics, nakhona banokupha a question on ama experiments, bangabuza nge-dependent or independent variable. So ku 5.1, but for this investigation, write down the dependent variable, and then the second question is the independent variable. So what is a dependent variable and what is an independent variable? An independent, starting independent variable. An independent variable, it's a variable okhona ukuyi-change wena, ne? Like for instance, like in this picture engizokhomba yona manje lena ikhombisa 2 yama plants. On the left you have a plant where unelo kanje une pot of plant, ne? nangabe utshalile kulawo ma-pots lawo, let's say mhlambe utshale ispinach or utshale ama-peanuts or utshale whatever or an orange tree, ne? The only variable ongayichange lapha yini ukuthi uthelelela ngakanani on a daily basis or on an hourly basis depending on the demand yaleyo plant. Yinto okhona ukuyicontrola yini amanzi. Another thing ongakhona ukuyicontrola yini ama-fertilizer. So leyo yi-independent variable, into ongakhona ukuyichange ke le. And then on the right hand side siba ne-dependent variables. There's a lot of dependent variables sikulelo kanje kulama-pots wama-plants lawo. Uyabona ukuthi lana sesinama plants akhulile, are fully grown ke manje. Lawo ma-plants lawo fully grown kunama-dependent variables lapho, ne? Ama-dependent variables, it's like one of them could be the height of the plant, loko awukhona ukucontrola lo. Angisho izodependa ngale change oyenzile before the plant izovela. The size of the leaves, ama-dependent variable. It's something ongana control over yona, but izodependa ngale change oyenzile. Uyabona? So basically singayisummarize sithi an independent variable, it's a variable okhona ukuyi-change in an experiment. A dependent variable, it's sort of like the outcome of the experiment. Like in this case, you want to study the reaction rate. So we can't dictate ilogaj. Well, it depends on what this is, what kind of substances for the reaction. For the reaction is affect the reaction rate, but reaction rate are equal izandleni zethu. So to answer these two questions, 5.1, question 5, 5.1, 5.1.1, the dependent variable is the reaction rate. It's the reaction rate. 5.1.2, it's the independent variable. The independent variable, the concentration is kept constant, the volume is kept constant. Now I will change in X, temperature will change, this will remain constant. The only thing we change for the experiments, it's for experiment A, I was 7 ama granule. Then go experiment B, I change 7 ama lumps. So it means the independent variable, the variable is going to change it's the state of division. It's the state of division, right? It's the state of division. So 5.1 uphelela la. The carbon dioxide gas, CO2 gas produced during experiment A is collected in a gas syringe. So during that experiment, mhlambe bangayenza in a closed container, then phezulu kule container mhlambe bangahlohla iluka i-syringe, so that the experiment na i-progress kanje bakwazi ukucollecta i-gas. And then the volume of gas collected is measured every 20 seconds. We have a graph lana on the y-axis, sinani, volume of carbon dioxide gas in centimeters, cubic centimeters, and then on the x-axis in a cut. Every 20 seconds you record, every 20 seconds you record, every 20 seconds you record, so on and so on. Ne? Just explain a little graphly. Ne? Now, assizing up again. 5.2. What can be deduced from the graph regarding the rate of reaction during the time interval between 20 seconds and 40 seconds? Between 20 seconds and 40 seconds, minangbona an increase on the reaction rate. Reaction rate. Why there's an increase? Draw a line. If you draw a line, this line has a positive slope. Ne? Now sesikhuluma in terms of sikhuluma ngama mathematical terms ke manje. Slope of the graph, ne? A slope eslanta to the right, siyazi ukuthi sinani, sine positive slope. A slope esislanta this way, it means sinani, sine negative slope. So the reaction rate, in fact, the gradient or the slope for this graph izosinikeza the reaction rate, ne? Because the slope is the volume divided by time. The change in volume divided by change in time is nikeza the slope. So that's the reaction rate in essence. So between 20 seconds and 40 seconds, there's an increase in the reaction rate. Okay, so we're on 5.2, 5.2.1. There's an increase in reaction rate. 5.2.2. Okay. As but I'm thinking of something. Okay, yeah. Between 60 and 120. Between 60 and 120, now we have a horizontal slope. So the gradient is 0. The gradient is positive, the gradient is 0. So therefore, between 60 and 0, the gradient is 0. The gradient is 0. Therefore the reaction rate is also 0. Is also 0. Yes, 5.2 pelelalana again. Now 5.3, calculate the average rate in cubic centimeters per second at which carbon dioxide is produced in the experiment. So therefore, spilagla graph lena, so calculate the average rate, the average reaction rate. So therefore, as pegi graph yethu ke ngitheni, the slope of this graph izosinikeza our reaction rate, but between 60 and 120 we have 0. So therefore sifuna the average the average gradient. So the gradient yethu sizoyicalculate where there's change on the graph. From 0 to 60 seconds, I see change la. Increase, eventually iba 0. Ne? There's no reaction rate manje la. Angisho the carbon dioxide siyabona ukuthi as it progress chemical reaction yethu, when calcium carbonate and hydrochloric acid nazi reactors form in carbon dioxide. So the mass ye carbon dioxide or the volume of carbon dioxide is increase gradually until reaction yethu yenzani iphele. So therefore there's change between 0 and 60. Ngoba after 60 the reaction stops. So therefore our average gradient will be calculated between time 60 and time 0. So reaction rate is 5.3. Yes, 5.3. City average. Average rate is equal to change in volume of carbon dioxide divided by change in time. So is equal to, actually it's final volume subtract initial volume. final time subtract initial time equal to, what's the final volume? The final volume, as is a sketch set, it's what? It's 500. It's 500. And if reaction is 60 seconds, so the final volume or the total volume for the whole reaction is about 500. Subtract initial volume was 0. Initially, I'm sure carbon dioxide is a product, so therefore initially we have 0 product, but as the reaction progress, the mass or the gas for a product here to is or increase, so therefore initially we had 0 volume. Final time 60 seconds minus initial time 0. So let's calculate. So basically it's 500 divided by 60. Answer is 8,33 in 2 decimal places. Centimeter cube per second. Or normal so 88,33 centimeter cubed per second. My balance as well. Next question, 5.3. Okay, 5.4. How will the volume of carbon dioxide produced in experiment B compare to that produced in experiment A? Choose from greater than, smaller than, or equal to. 5.4. The volume A produced by experiment B, the volume of carbon dioxide produced in experiment B compared to that of experiment A. Check again. Now, check again. I-reaction nayiphela whether usebenzisa ama-granules or ama-lumps, ne? Okusalayo ukuthi sisebenzise the same mass of calcium carbonate. The same mass of calcium carbonate is used in all the experiments, ne? Whether usebenzisa ama-granules or ama-lumps or a powder, it doesn't matter, but at the end of the chemical reaction, volume for the carbon dioxide will be the same for all the experiments. So therefore answer here to Lana is equal to 5.4. 5.4 is equal to, this is our answer. This is our answer. The volume produced for carbon dioxide will be equal to the one produced in experiment A, for the fact that it's the same amount of mass for a calcium carbonate. 5.5. A graph is now drawn for experiment C on the same set of axes. How will the gradient of this graph compare to the gradient of the graph for experiment A? Choose from greater than, smaller than, or equal to. Alright, since it's so. Now, experiment A, there were granules used for the calcium carbonate. Now, we experiment C. We can see that sebasebenzisa ini powder, ne? And the powder provide a more surface area or contact area for hydrochloric acid and the calcium carbonate than the granules. The powder has more surface area than the granules, so therefore this one, experiment A, experiment C, uzoba much more faster, or uzoba this experiment is happen more, izowenzeka much more faster than experiment A. Why? Because learning a more surface area. This substance, the calcium carbonate, has more surface area than ama granule. So the acid, the hydrochloric acid has more expose again kakhulu ku calcium carbonate than ku A. So therefore kuba na more effective collisions between lama substances lawo. Bese le reaction, that's why iyenzeka much more faster. So therefore I'm expecting ukuthi igraph ka C iyenze something like this. Iyenze something like this. Izoba ne gradient a much more. Izoba ne gradient a steep, ne? Or izoba ne greater gradient compared to the one in experiment A. So to answer to 5.5, I can say singathi mhlambe read the question. Isoba great. Okay, but a graph is now drawn from for experiment C on the same set of axes. How will the gradient of this graph compare to the gradient of the graph for experiment A? Choose from. It's going to be greater than. Our answer is greater than. Is greater than. But in Bonabati it's 4 marks. Oh, okay. Use the collision theory to fully explain the answer. Now, to use if you look at collision theory to explain the answer A to CT, the reaction rate for experiment C will be greater than A, ne? Will be greater than A. Maybe singathi because dot full stop, because the surface area, basically it's whatever we need discuss another area of calcium carbonate, because the surface area of calcium carbonate in experiment C is greater than the one in experiment A, and more effective collisions per unit time, and more effective collisions per unit time will occur. Right, this is something ungabhala something around these lines la, ne? But the keywords la ngasho ngithi it's effective collisions. Ungakhohlwa mention something like a surface area. Effective collision, it's a keyword kuphi ivela kuphi ku collision theory. So therefore now that use collision theory to explain blah 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 blah. So yazi ukuthi okay, in my explanation I must use ama keywords afana na effective collision, surface area, concentration, pressure, yabona bukhuluma ngama gases, na bukhuluma ngama solutions, kwamele umention abo concentration along those lines. So 5.6, the last question, but assume that the molar gas volume at 40 degrees Celsius is 25.7 cubic decimeters per mole. Calculate the mass of calcium carbonate used in experiment A. I think the chemical reaction plus hydrochloric acid siproducer ini konje calcium chloride plus H2O plus carbon dioxide. So this is our chemical reaction. So therefore, what at 40 degrees Celsius, assume that if molar volume, that's Vm, is equal to 25.7 cubic decimeters per mole. Sifuna ukwazi i-mass for calcium carbonate ebayisebenzisile. So therefore sizosebenzisa stoichiometry la. Yeah, sizosebenzisa i-stoichiometry la, ne? Sizosebenzisa i-stoichiometry to calculate the mass. But before we can perform a calculation, we need to convert volume produced, the volume produced for a carbon dioxide, ne? We need the volume produced for the volume of a carbon dioxide produced, ne? As per the graph here. So I want to put on the graph i-experiment nayiphela. Uma iphela i-experiment siyabona ukuthi the volume of carbon dioxide produced is what? It's 500 cubic centimeters. So carbon dioxide produced is equal to 500 cubic centimeters. But since molar volume is in cubic decimeters, we are going to convert cubic centimeters to molar, so cubic decimeters. So divide down 1,000 to 0.5 cubic decimeters. So now saying the volume of the carbon dioxide produced, which is equal to this one. Sithatha from the graph. So now I'm calculating the number of moles for a carbon dioxide before I can calculate the mass yangale, because in stoichiometry we only compare the number of moles between substances in question. So the number of moles of carbon dioxide is equal to volume divided by molar volume, equal to, this is a formula. This is another formula for calculating the number of moles. The number of moles, if baguphi mass, I calculate as mass divided by molar mass. But since basiphe molar volume, sizodinga ukusebenzisa volume produced to calculate the number of moles. So volume produced is 0.5, molar volume is 25.7. So 0.5 divided by 25.7 is equal to, I think it quote in 4 decimal places, 4 decimal places. Our answer is equal to 0.0195 mole. Ne? You quote in 2 decimal places. Ngoba ngibuka ukuthi it's 0.0. So ngifuna 3 numbers after the 0. Why ngifuna 3 numbers? For accuracy's sake. For accuracy's sake. Therefore, saying the number of moles for a carbon dioxide. So according to the equation, there's a 1:1 ratio. For every 1 mole of calcium carbonate, there's 1 mole. There's 1 mole of carbon dioxide produced. Ne? So if we produce 0.0195 mole of carbon dioxide, it means 0.0195 mole of calcium carbonate should be used. There's a 1:1 ratio between carbon dioxide and calcium carbonate according to the equation. What is 1:1 ratios? Because ama-coefficients wethu la ku-carbon dioxide na ku-calcium carbonate is 1 and 1. So nangabe ngina 1 mole ye-calcium carbonate izoproducer 1 mole of carbon dioxide. So if there's 1-to-1 ratio and 0,0195 was produced the carbon dioxide, it means 0,0195 of calcium carbonate was used. So therefore the number of moles for calcium carbonate is equal to mass over molar mass. Why ngisebenzisa le formula sengifuna i-mass manje. I have the number of moles now. I'm looking for the mass produced. That's the question. It is told the mass produced for calcium carbonate. Now we need to calculate the mass of calcium carbonate used in experiment A. Ngifuna i-mass, molar mass ke. So let me substitute the number of moles for calcium carbonate is 0,0195 is equal to mass. We want to calculate what's the molar mass of calcium carbonate. See, I got periodic table. Calcium has a molar mass of 40, so it's 40 plus carbon has a molar mass of 12, and then how about oxygen? Oxygen it's 16, so it's 3 times 16 equal to 195. Mass is equal to 40 plus 12 plus 3 times 16 is equal to 100. So therefore mass is equal to cross multiply again man. Question paper cross multiply again man. So this, or the LCD is a multiplier both sides of the equation. The LCM cancel ngifuna ukusala no m kuphela. So it's 100 times 0,0195. Answer is 1,95 grams of calcium carbonate was used. So this is our final answer. Thanks for watching. Ngizobona on the next video. Check out that videos in the description below. Please ngicela uwabukele now, because I feel like abalulekile now, yabona, because maybe uyastudisha la ukhona, next week uyabhala, or tomorrow uyabhala, or next month uyabhala. So lamanye ama video na uzowabukela azokunceda, ne? In the description below uzowabona ama links for wonke ama questions akhona in this question paper. Nangabe uyi-enjoyile this video, leave a thumbs up. Leave a comment in the comment section. Let us discuss la nunga understand the corner. And then now we're new to this channel, please consider subscribing. Thanks for watching. Ngizobona on the next video.